the adventure of Virgil's school. I will try my best to be clear. It's going to be a little bit different. So we're talking about scale factor, and I did want you to watch that first video before you watch this, just so you can get an idea. That guy explains it very, very well. So scale models are similar figures. We just did indirect measures. That means they have the same angles. They are proportional. They are the same shape. So you guys know what it is to have model airplanes and cars, and this is about how many times the actual object is than the model. You do have to have it in the same units. So we'll look at this first one, and it says a model airplane is 1/24th or 1 to 24th the size of the actual airplane. So we have to put, here's the model, it's the 1. The actual object is the 24. And then the wingspan of the model is 18 inches. And then we don't know what the wingspan of the actual airplane is. So in this case, we would cross multiply and divide. And if I give you a second, you can multiply that, and we would end up with 432 inches. Of course, you guys aren't going to want to do the actual airplane in inches. You are actually going to divide that by 12 inches because there is 12 inches in 1 foot to get 36 feet. Now, they're showing you right here as we look at the graph that scale factor is directly proportional. If you have 0 inches, you're going to have 0 feet. But as you go up in inches, you're going to go up in feet. That seems obvious, but remember, you'll get a lot of questions about, is this relationship directly proportional? Yes, scale factor is directly proportional. We have another one where Sophia is molding a model car from clay, which we often do, right? The scale of the model is 1 to 36. So if the height of the actual car is 4 feet and 6 inches, what should the height of the model be? So the model is always 1. And the object is going to be 36 times bigger. As far as the actual height, it changes a little bit if we're talking area or volume, but we're talking about height right now. So first of all, you are going to want to take 4 feet and 6 inches, and you are going to want to change that to all inches. So of course we know there are 12 inches in a foot. So 12 times 4, which is 48, plus 6, which is 54. Okay, so that is how many inches that the actual object is. So it would look like this. We would put the actual object is 54 inches. And we want to know what the model would be. So we are wondering about how tall the model is. So we go 1 times 54 divided by 36. And we find out that the model has the length of 1 1/2 inches. Remember, you guys can do this part with your calculator, really work it out, but we don't want to spend too much time on that. Okay, we're going to continue on with this, and now we're going to talk about how to actually figure out what the scale factor of the objects is. Right here we have 2 similar triangles, and we want to see what their scale factor is. First of all, we need to select corresponding sides to figure out the scale factor. So this one corresponds to this one right here, and we simply actually divide. So we have the smaller one, which would be the scale, and so we would do 20, whatever we want to call the variable x, equals 25 for the bigger triangle to figure out what the actual scale factor is. So we're going to go ahead and divide by 20 to get x by itself. 20 on this side. And we end up with x equals 25 over 20. We'll go ahead and simplify that into a decimal, which ends up being that the scale factor is 1 and 25 hundredths, or 1 and 1/4 times bigger. So that would be how to find the scale factor. Now we are going to talk about the fact that if we were talking about scale factor as far as just the side of a cube, it's different than finding the actual scale factor as either volume or for area. For example, one side of cube A is 1, and the side of cube B is 2. So the scale factor is 1 to 2. Now, let's say we change that to area. We actually do the scale factor of the area of cube A and cube B. So for area, we would do a length by a length, or a side by a side. So we have 1 times 1, which equals 1. So 1 square centimeters for a side of cube A. Then for cube B, we have 2 centimeters times 2 centimeters, which ends up being 4 square centimeters. So that changes right there. The area actually changes the scale factor from 1 to 2 to 1 to 4. Now if we were going to talk about volume, for the smaller cube, the volume is 1 centimeter times 1 centimeter times 1 centimeter, which ends up being 1 cubic centimeter. For the 2-inch cube, it is 2 centimeters times 2 times 2 centimeters, which ends up being 8 cubic centimeters. So that means it changes with volume. It just keeps going up exponentially from one side to area to volume, because now the scale factor for volume would be 1 to 8. So 1 to 8 for volume. I'm making a mess here. Let me fix this. Okay, so for volume, 1 to 8, area, 1 to 4, and for length, 1 to 2. We're illustrating how volume, area, and side length is very different, a very different scale factor. So we have 2 rectangular prisms. The smaller one is 2 centimeters by 3 centimeters. Whoops, that's a weird centimeter right there. By 4 centimeters. The larger one is 6 centimeters by 9 centimeters by 12 centimeters. So what is the scale factor from the smaller prism to the larger prism? So if we're just talking about side length, we have 2 similar sides, 2 corresponding sides right here, this side and this side. So we're going to do the scale factor of 2x equals 6x, or sorry, not 6x, but 6. We're going to divide, and it's going to end up being, the scale factor of a side will end up being x equals 3, where the scale factor is 3. Now, when we do an actual face or an area of 2 corresponding sides, we have this one right here and this one right here. So for the first side, we have 2 times 3 equals 6 square centimeters. And then 6 times 9, which equals 54 square centimeters. So then when we do the scale factor, which is 6x equals 54. We divide. And then for the actual area, the scale factor is a scale factor of 9. Okay, so for the area, it's a scale factor of 9. Now we're going to talk about volume. Okay, so I'm going to go ahead. Well, I guess we'll move down a little bit, or we'll come up here, actually, and we'll do the volume of each. So the volume of the first prism is 2 times 3 times 4 centimeters, which equals 24 cubic centimeters. And for the larger prism, we have 6 times 9 times 12, which ends up being 648 cubic centimeters. So again, we figure out what the scale factor is, and it's 24 cubic centimeters and 648 cubic centimeters. And we divide to make that just a 1. Divide this, and we find out that the scale factor when we do volume is 27 times bigger. So it ends up being 27 times bigger to have a volume than have an actual side, which makes sense. If you were to measure the actual side of like a little car and a big one, you would get a scale factor that would not seem that much larger. But if you do the actual volume, that's going to be 27 times bigger. So just realize that there's a difference between scale factor for area, or for one side length, scale factor for area, scale factor for volume. Now I'm going to ask you to try a couple scale factor problems at the first of your assignment. Then you can watch the video where I actually work those problems out to see how you did, and it will explain further what you needed to do. All right. Hopefully these will get better as I go. And you guys work hard. Have a great day.